Right now, your exact position in space is changing at a terrifying speed. Our entire galaxy is caught in a violent, active flight, hurtling away from an immense expanse of nothingness deep in the dark. We can measure the exact scale of this cosmic migration. By tracking our movement against the cosmic microwave background, astronomers know that the Milky Way, Andromeda, and our local group are rocketing through the universe at 631 kilometers per second. For decades, the scientific consensus offered a simple explanation for this extreme velocity. We assumed we were just falling. We looked ahead of our flight path and saw the Great Attractor and the Shapley Supercluster, immense concentrations of thousands of galaxies, and concluded their collective gravity was simply pulling us in. But when cosmologists finally mapped the exact mass of those structures, the math broke down. Gravitational attraction alone cannot explain our terrifying speed. Our basic understanding of our place in the universe is missing a massive variable. To find the missing variable, astronomers had to catalog the exact distribution of matter ahead of us. They calculated the total mass of the Shapley Supercluster to determine exactly how hard its gravity was pulling on the local group. This data visualization balances our speed against that pulling force, revealing a massive discrepancy. Shapley's gravity only accounts for half of our velocity. To balance the equation, if the pull ahead isn't strong enough, an equal force must be pushing us from behind. Humanity is caught in a cosmic vice. We are being actively squeezed between a massive cluster of galaxies pulling us forward and a terrifying expanse of absolute darkness pushing us from behind. Finding this invisible force presents an immediate methodological problem. Traditional telescopes map the universe by capturing light from stars and gas. You cannot photograph a void, because an absence of matter emits no light. To see what was pushing us, astronomers from the Cosmic Flows project had to stop looking for light and start looking for motion. They measured the peculiar velocities of thousands of nearby galaxies. By subtracting the baseline expansion of the universe itself, they isolated exactly how these galaxies were physically flowing through space due to local gravitational forces. This 3D visualization shows the result of that velocity mapping. The directional streamlines track the flow of thousands of galaxies, forming a perfect dipole pattern. You can see the streams converging on one massive knot of matter on the left, but more importantly, you can see them rapidly diverging from a completely empty point on the right. This empty diverging point is perfectly anti-aligned with our trajectory. It is the exact location of the invisible force pushing us. Astronomers named it the Dipole Repeller. By charting the universe as a topographical watershed, mapping where matter flows rather than where it sits, researchers proved this invisible repeller is real. It acts as a massive cosmic current that we simply cannot escape. This raises a paradoxical question in physics. Without relying on mystical concepts like anti-gravity, how can a region of absolute emptiness physically push a galaxy? Look at this 2D spatial model to see the physical baseline. In a perfectly uniform universe, a galaxy experiences equal gravitational attraction from every direction. All those pulling forces cancel each other out, resulting in zero net motion. But watch what happens if you carve out a massive void in that uniform space. You remove the mass that was pulling from that direction, creating a severe gravitational deficit. The pull from the remaining matter suddenly dominates. Physicists call this effective repulsion. Because there is a severe lack of gravitational attraction relative to the cosmic average, an underdense region behaves identically to a repulsive physical force. It shoves matter away simply by refusing to pull it back. Emptiness in space is not a passive, inert vacuum. It is a steep mountain in the gravitational landscape, actively forcing all surrounding matter to flow downhill. Zooming out past our local neighborhood, cosmologists now map the entire universe as a velocity web, or V-web. Across billions of light years, the cosmos operates entirely on this relentless dance of push and pull. Galaxies, superclusters, and massive cosmic filaments do not form passively. They are actively squeezed into dense thread-like structures by the immense outward pressure of the surrounding voids. Voids like the Dipole Repeller are the actual sculptors of spacetime. They operate as the engines that power the bulk flow of matter, dictating the physical structure of the universe across hundreds of millions of light years. These voids act as the primary architects of cosmic evolution, dictating the long-range currents that define the entire velocity web. we can now project the long-term trajectory of the Milky Way. We are currently caught in the crossfire, squeezed relentlessly by the outward expansion of the Dipole Repeller and the inward pull of the Shapley Attractor. If gravity ultimately wins this tug-of-war, the endgame is a violent collision. Pushed and pulled along the cosmic current, our local group of galaxies will be crushed into the Shapley Supercluster in less than 100 billion years. But there is a competing cosmic threat. Dark energy is driving the expansion of the universe to accelerate. Long before we ever reach the attractor, this accelerating expansion threatens to stretch the physical space between galaxies so fast that our entire supercluster is torn apart, leaving us completely isolated in the dark. Our ultimate destiny will be dictated entirely by an expanse of absolute nothingness. Whether we are crushed into a supercluster or stretched into isolation, we are at the mercy of the void. On a cosmic scale, emptiness possesses the most